I thank everyone who joined here for today's webinar. My name is Anshidivya from 3rd Civil from Sanskrithi School of Engineering College, Puttaparthi. Today, we are having webinar on special concrete presenting by our Honorable Chief Guest, Dr. Jagadish Vengala Garu, Associate Professor, working as Head EDC, Innovation and Incubation Center, and as Associate Professor, Department of Doctoral Degree on Seismic Response Study of Bamboo-Based Constructions from VTU, Belagavi during 2015, and also obtained his Master Degree in Construction Technology from BMS College of Engineering, Bangalore in 2002, and Bachelor's Degree in Civil Engineering from Koneru Lakshmaya College of Engineering, Vijayawada in 1998. After 2 years as a design engineer at Steel Research Foundation, Bangalore, he joined IPIRTI as a scientist in August 2004 and worked he left the government job and started formal teaching from 2015. He was recipient of Distinguished Professor Award by 2019, Vishwakarma Award in 2013. He was recipient of Professor V. Ramakrishnan's Youngest Scientist Award for year 2008 and 2009 by Indian Concrete Institute and international forums. He has chaired and co-chaired more than 25 sessions in international training programs. He also published about 42 research papers and he has got more than very blessed and thankful to have you here, sir. And we are super excited to have your lectures here. Honorable Chief Guest, Dr. Jagadish Garu. Sir, now you can start, sir.
To Department of Civil Engineering, Sanskrithi School of Engineering and Technology. 10:15 and by 11:15 I'll finish my lecture and I will open for questions for about 15 minutes because I have one more talk at 10:30. Okay, so with that, let me quickly get into the topic. Let me share my screen. Hope you can see my screen. One of you confirm. Can you able to see my screen?
Yes, sir.
Okay, let me get into the content of my presentation. So this is the next in that wherein I started working with this special concrete, the name self-compact and that other types of concretes like fiber reinforced, translucent, ultra high performance, decorative. So without before getting to that, I'll give you a glimpse like how the current concrete practices in let us see this particular video wherein this is how the manually produced site mix concrete quality we are maintaining. Why I'm showing this video is, all of you must carefully go through it. This is the video I have taken in front of my house, wherein people are putting the aggregate, the sand, putting the water after putting one bag of cement. So the very important thing, I don't know, you people observe. Let me quickly, go through it. So the mixer is rotating on its own. The mixing operator is doing some other work. He doesn't know, like, what is happening in the mixer. And the other laborer keep putting. You can see the concrete coarse aggregate into the mixer. Do you agree that the proper mixing is happened? No, because just now she has put one bunch of coarse aggregate, and and the concrete is going up. For the roof slab. This is how you cannot just be left to the judgment or guesswork of the concrete mixer, because he just keep on putting the whatever the amount of he is doing it. So in that, not happening properly. Okay, the mixing is not happening properly. So it is very complicated, that if you change any amount of material in the concrete mix, it will affect the properties of the concrete, both fresh and hardened properties. How fresh properties get affected, because if there is a change in the aggregate, change in the voids, and more voids will give you the more strength and other properties. So this is a normal concrete. So over a period of time, the concrete has been shifted to site based and RMC batching plants. So based on the awareness levels, people are opting for either ready mix concrete or the site based batching plants. Why? Because people are preferring RMC, because most of the cities, you have the houses surrounding you, and you don't have place to make the concrete in and around, and it causes a lot of disturbance and noise, a lot of pollution. So people are getting the ready mix concrete from the RMC plants, and because the quality is maintained at RMC plants, or if it is a bigger project, people are going for the site based batching plant. Each one of you must know the entire concrete, whether you do special concrete, whether you do a normal concrete, the concrete based on 5 exposure conditions. Conditions is very, very important. When you go through the IS 456, you can see clearly there are 5 exposure conditions, that is mild, moderate, severe, very severe, and extreme. All the marine environment, the coastal regions comes under severe condition without any problem. Even though if you are in a mild region, the foundations, the footings, the concrete which you place below the ground level goes to moderate level. So you are casting where it is placed, or the concrete is, are you placing it below the footing, or depending upon the environmental condition, you decide the concrete mix proportion which you need to design. So here for conditions, mild is minimum is M20. So any RCC structure, you go with the M20 minimum. If it is an extreme condition, you go with the M40 grade of concrete. And very important, ratio, maximum free water with a 0.05 difference. This is my moderate 0.5, severe and very severe it is same 0.45, extreme it is 0.4. Similarly, the minimum cement content you have to maintain to get the desired strength and desired properties is 300 kg per cubic meter for any concrete. At the same time, for extreme conditions, cubic meter. If you look into the entire the concrete, somebody's mic has to be muted. Some sound is I'm getting. Um, one second, check. It is muted now. Okay, fine. So what I mean to say, the cement what we are putting in for RCC is between 300. Maximum cement we can put in a normal concrete is 400 kgs of cement. And maximum water cement ratio, you can see from the table 0.55. Grade of concrete is between 20 to 40, and I6 permit you to use the mineral admixtures and chemical admixtures. Prashant, I can I mute? How to mute? Who is having the host option?
Me and Mamta.
Please do that, na? Please mute who is creating problem. Divya Prashant is she's not muted.
Sir, you are in mute, sir.
Okay, fine. So permit you to use the mineral admixtures like fly ash, rice husk ash, and even the chemical admixtures also. But when you have to make a special concrete, particularly from normal concrete to if you wanted to go for a concrete, by just adding water, you cannot make, because if you have to pump the concrete, you need to make it fluid. You need to make it fluid. Concrete by just adding the water? No. So if you just add the water, what will happen in fresh properties, in fresh state of the concrete, it will leads to segregation and bleeding. Segregation is a different and bleeding is different. Segregation is separating it out of the all the particles. Bleeding is the excess water comes out of the mix. So in hardened state, what will happen if you just add the water simply, it will lead to the durability problems. Why? Because it creates a lot of voids in the. So adding water, taking the help of chemical admixtures. Chemical admixtures in a we use two types, like one is plasticizer. We also have the high range water reducing admixtures. That means super plasticizer have a stop the reaction for some time. We also have the accelerators, air entraining agent. A lot of chemical admixtures are there where you can mix in the concrete depending upon the purpose what you are using it for. So how admixture works, I will let explain in a simple. What happens when you add the water to the cement? Cement is put together. So lot of water get trapped inside these flocks. Water will get trapped. Is not to get the more workable by adding admixture to the concrete because of the various the concepts. It will deflocculate the cement. So what happens if these particles get deflocculate? That is there, it gets released, and so that cement particles move freely, and then that's how the workability increases. This is how the mechanism of the super plasticizer or a plasticizer. So what happens when you have the more water that is available, so the more cement hydration that happens, more CSH particles will form, so more dense concrete or more strength you get in the concrete. Similarly, this is how the mechanism, the reaction that you can see. Cement flocks, emulsion, adding either plasticizer or super plasticizer, different charges in the cement part. So inside these flocks will get released. This is the action of the super plasticizer. You can see a picture wherein right side you have the flocculated mix, the left side you have the deflocculated mix, that is the mix which is having get separated. This is how the you can see in the microscopic. What exactly the super plasticizer will do? Are we using it for increase the slump or increase strength? This is the control concrete. If you look into the control concrete, you have the mix with the 0.55 and 75 is your slump and 50 super plasticizer or plasticizer. We are increasing the slump without changing the water strength. Also will not here in this. In the last case, we are reducing the water cement ratio. At the same time, we are maintaining the slims. You are getting the more strength in this case. So water cement ratio to strength, you know the basic the relation. Cement ratio to strength, the water cement ratio increases, strength decreases, water cement ratio reduces, strength increases. Without changing the water cement ratio, if you want to increase changing the slump, if the strength, so you need to reduce the water of the superplastism. You make it will happen, particularly for reinforcement. If you place it from a certain height, what happens? The concrete gets separated out. So that's how the segregation happens. Only the cement particles, the mortar will get stick into the reinforcement, and all the coarse aggregate particles will separate it out. That is why, in IS, they've said the free fall height of the any concrete, it should be less than 1.5 meters. Very important. So less than 1.5 meter is the free fall height of the concrete. But you cannot avoid the congested reinforcement, because a lot of complex structures are coming up in India, and you need to go with complex reinforcement. But how do you make the flowable concrete without such as fly ash or silica fume, additional powder, more powder, but you can make the mix. But if you add powders, what will happen? It will increase the surface and will increase. At the same time, you can overcome this by adding. As we know that advanced methods of the placing is all complex structures are coming up. So congested structural reinforcement, the vibration, can you able to guarantee? Like, can you able to guarantee the vibration, and can you able to guarantee the quality of the concrete? No. So this is the kind of congested structural reinforcement. This picture was from one Japanese structure, wherein you can see the kind of congested structure. This is from see the kind of congested structural reinforcement. So what is the solution to place the concrete in? So self-compacting concrete is one of the solution, wherein this concrete is highly flowable, and it is a stable concrete, and it can readily spread places, and it can fill the formwork. Don't require to doing separation. They fill the entire formwork by flowing or moving through the congested reinforcement. So where is the origin of this particular concrete, this special concrete? This is introduced in Japanese construction industry in late 80s. What is the motivation behind? Because there is a gradual reduction in skilled labor in Japanese construction industry. Reduction in the quality of construction work. So that is how the SCC is originated. A lot of using SCC, one is you can minimize the voids in the concrete, you can shorten the concreting period, and you can ensure the compaction in the structure very well wherever the vibration is difficult, and you can completely eliminate the compaction. So what is the difference between the normal concrete and self-compacting concrete in terms of the powder content? Because normal concrete, as I mentioned, you can see 300 kg to the cement you. But in case of self-compacting concrete, in the order of 400 meter. What powder you have to use in SCC is 150 kg per cubic meter, and a lot of powder is required to push the coarse aggregate particle from one place to another place. And like normal concrete, you have a lot of coarse aggregate content, but in the case of concrete, either you have the equal coarse or otherwise you have the less ratio. And also superplasticizer, you use segregation control admixtures also you use. As I mentioned, powders are essential. It is in the order of 450 to 600 kgs per cubic meter of concrete. Why it is required? You in the suspension way of, because when you place the coarse aggregate, all the coarse aggregate particles, it should not sink and settle at the bottom. It should be always in the suspension mode, such that you have the homogeneity. You can achieve the homogeneity in the concrete, and the cohesiveness of the possible due to the cohesiveness, creating cohesiveness in the concrete. So cohesion, but as you know that cement we can use as per IS 4. When you have to go for 500 kgs of 500 kgs of cement, it's a heat of hydration, drying shrinkage, creep problems. So we have to look, the pozzolanic, use the inert materials such as non-pozzolanic materials. So IS 456, if you see the class, encourage you to use various supplementary cementitious materials such as fly ash, rice ash, GGB, microsilica, and alcofines. These are all available, and at various construction projects, they're already using it in quantities as per. I just wanted to mention the secondary reaction because you are using the supplementary cementitious material. What is secondary reaction? When you add water to the cement, there is a basic hydration process. The final product, what we get is CSH gel. So this CSH gel is nothing but calcium silicate hydrates. So number of calcium silicate hydrates will form. That is how the concrete is strong. Along with the concrete, it doesn't contribute. It remains there in the concrete for number of days, a number of years. When you add the supplementary cementitious materials like fly ash, GGBS, or silica fume, these excess lime, that is calcium hydroxide or portlandite, will again take part into the secondary reactions, that is calcium silicate hydrates. So in place of 100 CSH gels, if you add fly ash or any other supplementary cementitious, 25 CSH gels, that means more CSH gels creates more dense the is. So due to the secondary reaction, the more dense, the secondary reaction, supplementary cementitious materials, the secondary reaction and forming imparts the plus calcium, means water plus calcium oxide. It forms calcium hydroxide. It forms the CSH gel. So you can see the properties. So what all increases when you add the pozzolanas? It increases strength. It increases the impermeability. The particles, small pores, hollowness will be filled with these secondary materials. It increases the and also it increases when you have the concrete with the high dense in nature, it also increases compressive and tensile strength because you don't have any bleed pockets and you don't have any hollowness in the concrete. So when you look into the supplementary cementitious materials, fly ash is one of the ideal material, particularly for the self. Why? Because in India we generate fly ash through thermal of the power we are using, like Vijayawada thermal power station, VTPS, that is now station generating power. So how do they generate the power? By burning the coal. So after it is so that is nothing but we call it as a fly ash. So fly ash supplementary cementitious materials. Fly ash particles, when compared with the other particles, diameter is between 1 micrometer to 150 micrometer, and fly ash from precipitators, wherein you collect the fly ash from the thermal power stations. When you look into the microscopic view, you can cleanly observe the particle shape, spherical in nature, wherein it gives the ball bearing effect when you add it to the concrete, wherein the fresh properties or the workability increases because of the ball bearing effect of the fly ash particles, because those are materials like GGBS. This I have already explained reaction between the water and cement hydrate, excess calcium hydroxide it forms. When you add the fly ash will again react with, that is secondary reaction with calcium hydroxide in presence of water and forms excess calcium silicate hydrates, which imparts the strength. Using SCC, because we have when compared with silica fume or metacoline, the cost of the fly ash is you only have to spend on a transportation cost, and whether when you compare with the other materials like GGBS, silica fume or metacoline, GGBS one bag costs 180 rupees per bag. So cement is around 300, 350. So half the cost is your fly ash. And fly ash can be used for 300 kgs of in self-compacting concrete. You can go with the 250 kgs cement and 350 remaining kgs with the fly ash. That is why we call fly ash as ideal powder in self-compacting concrete. Concrete, there are three properties: ability, passing. One, completely all spaces within the formwork, that is under its own weight, very important. Passing ability is when you place the concrete, this concrete has to flow through the tight openings of the reinforcement without getting segregated or without blocking, because the reinforcement you have in the coarse aggregate. Okay, so the concrete uh, should not get segregated, so that it should pass through the reinforcement. Next is segregation resistance. In segregation resistance, SCC, it should be homogeneous throughout the mix, and it should during the transportation and placing, the excess water should not come out. The bleeding should not happen. Very important. So some of the test methods are like slump flow, J-ring, V-funnel, L-box, U-box, fill box, screen stability. Test, but there we test the vertical slump. Here in this case, self-compacting concrete, Abraham's cone. When you lift the cone, so the concrete spreads. So here you measure the horizontal spread, the average of the horizontal spread of the concrete. So this, once you lift the cone, so the concrete will flow. You measure the horizontal. In a regular normal concrete, you measure the vertical slump. Here you measure the horizontal slump, the diameter. So the slump flow in this centimeter measurement. What does that mean? Once you lift, the time 200 mm, the point, it will spread. The time taken to reach from 200 mm to 500 mm is the T50 centimeter. That is, it the video. So your the cone, the concrete will flow. So here you measure the, so you measure the horizontal flow of the concrete. Right? Yeah. Next test is V funnel test. So in V funnel test, many times is used fluid. Usually chemistry labs and all, whoever is testing, particularly for resin materials and other materials. Similarly, you have a V funnel wherein you fill the entire V funnel with the concrete and you measure the viscosity of the concrete. How do you measure time taken to reach a does it V funnel time? Recommended values are 8 to 12 seconds. You fill the V, you remove the bottom plate, and then you measure the measure the empty the entire V funnel. There is also measurement, we call it in normal, to fill the V funnel and immediately measure the time. This is like for problem in the mix, all the coarse aggregate particle get accumulated at the bottom portion of the V funnel. That is how when you open the bottom door, the time taken to empty the V funnel will be measured, and it should be recommended value is it should be less than the time taken at 0 minutes plus 3 seconds. It's less than that. Okay. Test. You fill the concrete. So you measure the time. Measure how much time it is taken. Similarly, you remain it, and you measure V 5 minutes. Next is the L box test. L box test is the passing ability test, wherein you have a one vertical box. So between these two, the junction, okay, you fill completely the vertical box, and you have a door. This door contains reinforcement. Lift the gate, so the entire should flow through these reinforcements and pass through the T20 centimeter, time taken to reach 200 centimeter, and time taken to reach 400. This is how you lift the gate. The vertical, the concrete that is there in the vertical box, either side of the height difference, that is h2 by h1. So this h2 by h1 should be greater than or equal to 0.8. What does that mean? Leveled. That means the SCC means maximum the than h2 by h1. It should be less than point or equal to this height difference is more. That means more blocking ratio is there. That's what it means. You can see the video. You lift the gate, it flows through the reinforcement. You measure the height at both the places, height at on the either side of the L box, and that is how you calculate the blocking ratio. That is, h2 by h1, it should be greater than or equal to the 0.8. Similarly, there is a test called U box. You have two limbs of U box. Similar to the L box, you have the gate and you have the reinforcement cage. And and at the same time, you have to measure the height difference between these two. This is how U box test. So you have the blockage in between. So you don't do vibration. You have to carefully. So once you fill the one side, lift the box. This thing. So you will then you the vertical reinforcement connecting to a J-ring. Inside J-ring, you keep the slump cone and fill the slump cone with the self-compacting concrete, and you lift the slump cone, and then this concrete flows through the J-ring, and the height difference between inside and outside of the J-ring should be less than 10 mm. And there is also fill box test. You from one side, wherein the entire concrete spread should be proper. See, sorry. Yeah, it should be completely filled. There should not be any problem. Okay. Yeah, this is how it should be. So once you pour it, there should not be any, the difference. It should be straight. Okay. So this is how you take a bucket of self approximately 15 minutes stand still. So you pour it in. So it should contain coarse aggregate. All these coarse aggregate particles will settle down. So that is how you measure the segregation resistance. It should be between 5 to 50. The mortar what you sieved to the original sample taken should be between 5 to 15%. This is the screen stability test. These are the various tests starting V funnel, 3 to 12 seconds, L box, 0.8 to 1, U box, fill box. So you can ask like, what are the tests you have to do? Can we have to do all the tests to check whether it is SCC or not? People follow different combinations of these tests. In Japan, they follow slum flow, V funnel, and U box. And in Sweden, they follow only slum flow and L box. In European countries, other people follow both. And we suggest slum flow and at 5 minutes. These are the tests you can follow for accepting SCC. Various applications are there. Osaka gas station in Japan. This is the first application of self-compacting concrete in Japan. So this is 1997, the empty reinforcement is used. And there's another application. I happen to visit this place. This is Akashi Kaiko Strait Bridge in Japan. This is a long bridge. So the abutment using the SCC, wherein they have used FACCE in this particular case. And in Delhi Metro Railway, DMRC, a lot of applications they've used SCC. This is the inside tunneling. They used SCC. Tunneling in Sweden, you can see. These are the precast concrete elements, making precast elements in Netherlands. They've used SCC. So these elements are, they made by pouring the SCC, and they lifted after that, and then you can see the beautiful wall elements using the finishing. You can see the kind of finishing we get. You can see usually a lot of people, a lot of equipment, but for in the case of SCC, you don't require many people. You just have to pour the concrete, and it goes, passes, and completely settles on its own by its own weight. Very important. So that's how the work started in January 2020. By October, the work completed for a commercial center in Italy. So that is the speed you get using SCC. This is an is in IT Chennai. So he did a lot of work initially, and these are the benches they created in Spain. So he was there in University of Decathlon. So this is a kind of architectural, the elements you can make using SCC. Some of the experiments we did. This is the work we did in year 2001-2. You can see the mixes. I'm not giving a lot of focus because we have to speak about other few concretes. So here you can see. So fly ash is used almost 160 kgs, 430 kgs of cement. So the total powder you can see is almost 600 kgs, almost 500 kgs. Slum flow you can see 635, and V funnel 3.5, 4.5 seconds. And GTM. The beautiful thing the cubes, you just have to pour. This is very important. But the beautiful the reaction of the concrete, or the beautiful reaction of fly ash, you can see in the long-term strength. The 28-day strength you can see is around 55 on 70 days. It is almost like 90 MPa. So it is a 66%, 70% strength achievement you will see after 270 days. This is the contribution of fly ash you can see. And compared with the normal concrete, it is almost same, equal, or a little higher in case of the SCC. Contents are typically in the range of 38% in the normal concrete, 40% in the next is made, and what are the properties important, how the applications are. Now we will go through quickly the fiber reinforced concrete. This will increase the ductility nature of the concrete, and it will improve the post-cracking behavior of the concrete, and also it will reduce the permeability concrete because it increases the denseness. So you can see the stress versus strain picture, that is modulus of elasticity. The plain concrete versus low fiber reinforced concrete versus high fiber volume. So the stress versus strain curve is almost much higher when compared with the plain concrete. If it is a with fibers, you can see the cracking or the bending behavior. Without fibers, it is brittle failure, you can see here. So the fibers will hold the concrete together, not to get cracked. So there are a lot of fibers. You can see steel fibers, glass fibers, which are available. Carbon fibers, cellulose fibers, natural fibers are available. Even synthetic fibers such as polypropylene fibers, nylon fibers, the shirts we make. So those fibers also we can use it in the concrete. Natural fibers like coir and hay. Recently, one paper I've published. So some of our colleague researchers has done on human hair, using human hair in the concrete. You can go through, you can type it in the Google and you can get the information. So these are the various properties of different fibers when we compare with the steel, glass, asbestos, rayon, cotton, nylon, acrylic fibers. So different properties are different to these materials. Depending upon the application, type of application, we use the kind of fiber. Some cases the elongation is more, some cases tensile strength is more, some cases Young's modulus is more, some cases the specific gravity differs. So depending upon the application, you choose these fibers. What are the various factors that affect the properties? You have to understand. One is volume, how much you add. Another one is aspect ratio of fiber. Aspect ratio is length to diameter of the fiber. And how do you orient the fibers, and what is the matrix stiffness? These are all factors which will affect the properties of the fiber reinforced concrete. So volumes, when you look into it, so volumes, it is, we call it as a low volume, moderate volume, and high volume. So less than 1%, we call it as a low volume. Typically for slabs and other applications, pavement application, horizontal applications, we go for the low volume fibers. That is 1% of volume. Moderate volume is between 1 to 2%. Usually construction of shotcretes like tunnel linings and other improved structures, we go for the 1 to 2%, because the concrete has to go when you with the pressure you shotcrete, so it has to go and stick there. So the fibers will help you out. So more fibers are required when compared with the the 1% fibers. High volume fibers, we use it for the high performance fiber reinforced composites. So there you use more than 2% of volume of fibers. And aspect ratio, as I mentioned, L by D ratio, length to diameter ratio of each single fiber. So beyond 75 ratio, in the sense, the relative strength, the relative toughness, there is not much of difference. So up to 75, that means from aspect ratio 0 to 75, there is an increase in the strength and toughness of the concrete when you add it. So orientation, direction of the load, and direction perpendicular to the load, or randomly you can distribute the fibers. So it also affects the properties of the concrete. And also depending upon the fiber stiffness. So energy absorption of these fibers also affects the properties of the concrete. One very important thing I wanted to mention here, particularly for the mixing, many people get confused and do wrong thing in the mixing sequence or mixing of these fibers. So you need to follow a specific procedure, particularly for the fiber reinforced concrete when you are making a mix. This is how the sequence is. So first you have to put 50% of coarse aggregates, then add 20% of fibers, then add remaining 50%. Then add another 20%. So every time you have to mix it, okay? And then again 50% sand, mix it. Again 20% fibers, mix it. Again 50% sand, mix it. Another 20%, mix it. Lastly, add cement, mix it. Remaining 20%, mix it. And lastly, add, after the dry mix is completed, you have to put the water and then mix it. This is how the mixing sequence. Many people, they don't follow and they don't get the correct result by not following the mixing sequence. Very, very important. You have to follow the mixing sequence. Applications of fiber reinforced concrete in India and abroad is plenty of applications, particularly road projects in Madura, and there is a Copenhagen, there is a power plant, a heating tunnel, Even the Heathrow Airport parking garage was made using the steel fibers. Manhole covers is made using precast fiber reinforcement. Have to see that the compressive strength increase. Suppose if you add steel fibers, polypropylene fibers, how the strength, the difference. So you can see the behavior of the specimen when it undergoes to the compressive strength. The brittle failure in case of without fibers, you can see the fiber not a brittle failure or a good failure in case of the fiber added concrete. Tensile strength also almost 140% to 200% when you add different fibers. You can see split tensile strength also. The fibers will hold the concrete not to get split. You can see the case with and without fiber in these pictures. Similarly, the impact strength. Impact strength is take a steel ball and from certain height, if you release it, it will go and hit the concrete specimen. You can see the brittleness or break when the concrete specimens are without fibers. You can see the specimens with fibers after the compression by creating the impact on the specimens. There is no brittle failure. Similarly, the shear strength, you can see the specimen is still intact after the test. Okay, for a given load, the same load is given to the fibers, reinforced concrete. For the same load, there is no failure. Tehri Dam, Uttarakhand, they've used a steel fiber reinforced concrete in Indian application. So this is about the fiber reinforced concrete. Coming to the lightweight concrete can be produced with a different densities from 300 to 1850 kgs. We call it as lightweight concrete. Three types you can produce lightweight concrete. One is using lightweight aggregate. You can reduce the density of the concrete. So what is the normal density of the concrete? 2400 average. That is between 2200 to 2600. So when you call lightweight concrete, it should be between 300 to 1850 kg per cubic meter. So how do you achieve the lightweight concrete? Three methods. One is incorporating lightweight aggregates like cinder. Sunken slabs we make in the houses. So in sunken slab, particularly the toilet portions, the sunken slab, use the cinder material, wherein by using that aggregate, you can reduce the density of the concrete. That's how we call it as lightweight concrete. Similarly, by inserting or the bubbles, you aerate the concrete. So that's how you get a aerated concrete. AAC block is such one example. And the third one is the no fines concrete. You don't add any sand. Cement paste will hold the coarse aggregate particles. So there is a lot of gap between coarse aggregate particles. That's how the density will reduce. These are the three ways you can achieve the lightweight concrete. So usually UK, France, and USA, they go for lightweight aggregate concrete. But in case of Scandinavian countries, European countries, wherein the ice forms, they go for the aerated concrete. No fines concrete is recently coming up. So this is an experiment we have done it at our college, wherein we've used the EPS beads as aggregates. Okay, wherein we could able to reduce the density up to 1200, 1500 with a strength of 10 MPa, 5 to 10 MPa. There is also structural lightweight concrete wherein you get a strength up to 17 MPa, and the concrete density should be less than 1850. This is good in soundproofing, sound absorption, and thermal insulation. Very important. Aerated concrete, either you can incorporate gas or you can create the foam. How do you do that? By inserting aluminum powder, and so you can see the AAC block is such one example wherein the AAC is nothing but autoclaved aerated concrete block wherein you create the foam inside. So we have conducted studies on AAC block versus normal concrete block wherein the thermal insulation property, wherein you can get the temperature difference almost 2 to 3 degrees centigrade when compared with the normal solid concrete block. So because of the hollowness or because of the more pores that are there in the AC block. Next is pervious concrete. Pervious concrete is no fines concrete, wherein when you pour the concrete, when you pour the water in on the concrete. So this is good for drainage applications in the sense, particularly the concrete. There's a car parking areas and other things, wherein the water drainage rate is 320 to 120 liters per meter square per minute. And here you use you create the porosity. The strength is between 3 to 20 MPa. Various applications, you can driveways, swimming pool decks, pavemented drains, sea walls, beach structures, they go for it because the water has to go through it, pass through. This is one such example you can see. So whenever rain comes, it goes and it absorbs and it drains through and it joins with the nearby river. Walkways also you can. So this is connected to the drainage wherein you can. Next is smart concretes. This is called conductive concrete, wherein it contains 2% of steel fibers and 20% of steel shavings. What does that mean? It will produce the heat, and this heat is almost 600 watts per meter square. This can be connected to the power source. So this is used for de-icing and prevention of icing. What happens when you connect to the power source, this get heated up. So particularly for the cold countries, they use this type of concrete, conductive concrete. Because there the problem is the road gets completely ice, the ice get forms. When you plug it to the power, so it will get heated up and then it will de-ice. Okay. And there is also pressure sensitive concrete, wherein you can insert the carbon fibers, and you monitor the bridge behavior or highway pavement behavior. So the failure behavior of this is called conductive concrete. Next is self-curing concrete. So here you use the lightweight aggregate concrete, which will hold the water and further, it will, cure on itself. You need not use any water for curing the self-curing concrete. Next is ultra high performance concrete, wherein the aggregate sizes is less. You add a lot of fine powder or fine materials into the concrete. We also call it as a reactive powder concrete. Applications are plenty, particularly for architectural applications. This ultra high performance concrete is used. You can get a strength of, believe me or not, 200 MPa strength. You can get it by creating ultra. Next is high density concrete. Density almost you get 5,200 kg per cubic meter you can produce. This is very important, high density concrete, particularly for the radiation applications, nuclear power plants and other things. Very, very important. These are used for radiation absorption. Particularly all the nuclear power plants, the concrete is used is high density concrete, which the density is almost 3,300 above. So this can be achieved by using so all the combinations of these concretes, we call it as a high performance concrete. So different applications, different properties it does contain. High density I've already mentioned. There are two types. One is electromagnetic waves and nuclear particles it will resist. So shielding ability it will improve, as I mentioned, high density concrete. Next is last, I'm coming to the last 5 minutes of my lecture. This is the 3D concrete printing. Recently you might have seen in the news, 3D concrete printing, one of the startup developed at IIT Chennai, they're making it. 3D concrete printing technique is very simple. You might have seen the 3D printers. So there is an extrusion based 3D printing and there is a binder jetting. So wherein you have a frame-based system wherein this actuator will move and place the concrete over there. That means robotic arm-based system. You can see this is in a small video. 1 second.
It cost about 230. Figured out a way to
this
build
is
the house
how,
in less than 2 days for a fraction of the
prints.
cost. Oh my, Omar Villafranca looks at this new approach.
This isn't a. This technology starts of Icon, one of the companies.
So you can see the actuator will pour the concrete. This is how it prints.
At quarter speed. At full speed, could have printed this house in 11.
So there are two types. One is mobile-based 3D concrete printer, wherein you can multiple locations you can go and place it. This will move. Easy to maneuver, and then it has got a concrete pump hose to robotic arm, and it prints the whatever program location it has. There is a fixed 3D concrete printer. You have to fix it, and this is for prototyping and precast application. Once you fix it, you cannot change it. Okay, so this is these are the two types of 3D concrete printing systems here. The last one is translucent concrete, wherein you can mix the glass fibers, acrylic rods, and let the light passes through this concrete. A small video. 1 second.
World called Conan
You can see this is the concrete. You can see the other side. The persons are moving. You can see some of the applications you can go for the translucent concrete. Next is a bendable concrete, wherein concrete when you do the flexure test, it breaks. But by adding polymer microfibers, you can even bend the concrete. You can see the video. The bending behavior. See, this is how it bends. This is a concrete. This is what we call it as a fiber rainbows, but a bendable concrete. The normal concrete it broke, but bendable concrete for the same the load, it is not breaking. Next is decorative concrete. You can add different types of additives, color additives. You can improve the aesthetics of the concrete. There is also polished concrete. So you make the concrete, you add the color additive, and you can polish it. You got a nice, what we call just like, so Ultratech is doing some of these works, particularly polished concrete. And there is also stained concrete, wherein you can get a different kinds of shades in the concrete. This is also, they're taking care, like Ultratech is doing a lot of work on this staining concrete. You can make concrete sinks and vessels using the concrete. There is a stamped concrete, is very simple. In the fresh state, you have to place the rubber pad of the desired shape, and then apply the load. You get the desired shape in the concrete. This is what we call it as stamped concrete. So with that, I have come to the end of my presentation. These are some of my references, and thank you. Over to the organizers. I'll maybe next 10 minutes, you can ask any of the questions you have. Just I'll give 5 minutes. You can ask the questions if you have quickly. Over to the organizers. Divya, are you there?
Good morning, sir. Divya left, sir.
Okay, fine. If anybody wanted to ask questions, they can ask. You can ask. I'll wait for 5 minutes. If you don't have questions, over to the organizers. So Parvez is trying to ask. You can type it if you have a problem with the audio. I can, in chat box, you can type it. I can answer your questions. Hope you have understood some of the concepts of the special concretes. I was a little fast because I need to cover different concretes. Hope at least you got some kind of idea about these special concretes. Jayashree, you would like to ask some question? Harish sir, are you there?
Yes, sir.
Yeah.
I think no doubt, sir. The subject
okay.
is very clear.
Okay.
Mamata, you can give vote of thanks.
Good morning, sir. My name is Mamata from 3rd Civil. It is my privilege to propose vote of thanks on this webinar session. First and foremost, I thank our webinar guest, Dr. Jagadish sir, for this knowledgeable session. In despite of his busy schedule, he spent his valuable time with us. My heartfelt thanks to our chairman sir, principal sir, head of the department, and faculty for providing this platform. Last but not least, I thank my Royal Civil Engineering friends for making this webinar section successful. Thank you. Have a nice day, sir.
Yeah, thank you. One small question he has asked: what happens if we neglect void ratio during mold? So void ratio is very important. You have to make sure that you have a less voids in the concrete. So that is how you have to design your mix, even if it is a normal concrete or a special concrete. So you have to see that less voids are. So that's why you have to go for the proper grading of the aggregates, proper grading of the material. So based on the grading of the aggregates, you have to design your mix. I hope Asad you got it. With that, thank you. If any questions are there, you can send me an email. You can type my name in Google. Okay, you can get the contact and you can contact me anytime. Thank you, one and all. Thank you for giving me the opportunity.
Thank you, sir.
Thank you, sir, for this opportunity.
Okay, sir. Thank you.
Okay, sir.